Welcome back, it's Rob again. We're going to carry on now by looking at a very similar concept to the last one we looked at. We're going to look at equivalent rates. So when we're talking about equivalent interest rates, it's a similar idea to calculating the annual effective rate. But now what I want to do instead is not get the rate compounded once a year, but to go to a different compounding frequency. So maybe they gave me a monthly compounded rate, but I'm curious to see what quarterly rate would give me the same result, or what semi-annual rate would give me the same result. So that's called an equivalent rate, where I go from one nominal rate to another. So maybe my loan accumulates interest at 7% semi-annually. What's the equivalent J12? That type of question. All right, so let's have a look. To convert one rate to another, we're going to really just set the two kind of accumulation factors equal to each other. All right, so let me show you what I mean by that. What's the equivalent J4 that matches a J12 equals 6%? Or in other words, what quarterly compounded rate would give me the same result as a monthly compounded rate of 6%? Well, the known rate here is the J12 equals 6%, isn't it? And in this case, M is 12 and I is equal to 0.005. What I want to do is find the matching J4. In this case, the M is going to be 4, isn't it? Well, let's go ahead. For the first one, for the known one, I've got 1 plus I to the power. I'm going to use this little formula here. So for the one I know, I've got 1.005 to the power of 12. Now for the one that I don't know, I've got 1 plus sort of an unknown I, don't I, to the power of 4. I could set these things equal to each other. How do I get little I all by itself? Well, let me show you. I end up with 1.005 power of 12. I'll take the fourth root, and that'll leave me over here on the right-hand side, 1 plus I. Now I'll just go ahead and subtract 1 from both sides, and that'll give me I. So we're going to work through it that way, and if I do that for little I get 0.015075125. So that's fine. Let's move up here. That's my little I per period. Now I'm into quarters, aren't I? So how do I get the J4? Well, that's going to be I times 4, which works out to be 6.03%. So 6.03% compounded quarterly will get you to the same place as a straight 6% compounded monthly. That kind of makes sense. It's compounded a little less often, isn't it? So it's going to need a little bit bigger nominal rate to make us get there. So that's the idea of what we do. We take 1 plus the I that we know, and we're raising it all to the power of the one we're starting with divided by the one we want to end up with, and then subtracting 1. Let's have a look at a few examples here to kind of get the hang of this. For a given interest rate of 10% compounded quarterly, let's work out the equivalent interest rate compounded annually. All right. Well, maybe just up top here. Let me put down the known amounts here. We had J4 is equal to 10%. That means M is 4 and I is 0.025. All right, now what I want to do annually, I want to end up with a J1. Well, that's going to be I times 1, isn't it, in the end? What's that going to work out to? Well, let's see. I is equal to the 1.025. I got that from up top. Raising it to the power of, I started with quarterly. I want to end up with annual. So 4 over 1. Subtract 1. 0.1038. Now how do I convert that back to a percent? Just move the decimal over 2, multiply by 1 here, and I get 10.10. 9.38% for my answer. Let's do one more. The first one, by the way, is also the annual effective rate, isn't it? Same idea. So the J1 is the annual effective rate. What about semi-annually? In this case, I want a J2, don't I? What's the J2? Well, let's first find little I. And 1.025. This time I'm converting from quarterly to semi-annual. See, so the exponents change now. 0.050625. That's going to give me then J2 is equal to 10.13% for this one. I had to multiply the I by 2, didn't I, to get to my J2. Let's look at one more. Monthly, this case I want a J12, so I'm going to work out I and then multiply whatever I get by 12. Going from quarterly to monthly, subtract 1. Now, like always, if you're having trouble with these exponents, just throw some brackets around them when you put them in your calculator, and that'll help make sure they work out okay for you. I'll go ahead and plug that in there, and I get 0.008264,838. I want to convert that to a J12, so I'll multiply that by 12, and I get 9.92%. Let's have a look at all of these guys. We started with 10% quarterly. When I compounded less often, like I did in these two guys, right here, annually and semi-annually, I needed to have more interest per year to make up the difference, didn't I? 10.38 or 10.13. When I compounded more often than quarterly, I could get away with a rate that was a little bit less than 10 because I was going to get an extra boost from that compounding effect. That's the idea of equivalent rates. Let's go ahead and give you a chance to try one out. Scotiabank offers 4% compounded monthly on my GIC. The Royal Bank offers to match that rate if I move my money over to them. What rate would they have to offer if their investment funds are compounded semi-annually? So go ahead and hit pause. See if you can work your way through this one. Take your time. And when you're ready, come on back and I'll go through it with you. All right, let's have a look. The known rate here is J12 is 4%. That means M is equal to is equal to 12. And I is 0.04 divided by 12. That's a long repeating decimal. Probably want to keep all of that in your calculator memory or just type it in as a fraction as you're doing your work to make sure you get the full accuracy there. And the one that we need is the J2, isn't it? So in that case, M is going to be equal to 2 for this guy. So I then is going to be 1 plus 0.04 over 12, or 1.0033333. Repeating, raised to the power of 12 over 2 minus 1, because I'm switching from monthly to semi-annual. 12 over 2, monthly to semi-annual. That's what we want to do each time. Minus 1. That gives you 0.020167,409. And now I want to convert that to a J2, so I'll multiply by 2. And that gives me 4.03%. So the Royal Bank, if they offer 4.03% compounded semi-annually, that'll be the same to me as 4% compounded monthly. I'd be happy and maybe I'd be willing to move over. That's it for now. These can be a little bit tricky at first. You're going to need to practice a few, I think, before you feel comfortable with them. So make sure you go through the rest of this section of the textbook. And then when you're done, go ahead and get ready for our compound interest quiz, our next quiz in D2L. Make sure you do that before the due date, and then we'll be all done compound interest.